problem number 2. Here we go. So looking at problem number 2, I can tell that many of you have zero idea how to graph absolute value functions. We did learn this last year, so I didn't really cover it. Again, I didn't reteach it, I guess I should say. So let's remind you how absolute value functions work. They're what do they look like? That's the first thing you should think of. A V, correct everybody? Absolute value functions are V's. So then shifting for all functions works the same. Left 2 up 1. Everybody, left 2 up 1. You should be fixing this on your paper. You should be completely doing this. Now, this is a 1 in front. Now, with absolute values, with V's, they work, this is a slope. They work like lines. But it's not a line, it's a V. So this is 1, which we can think of as 1 over 1. So positive 1, rise over run. So we're going up 1 over 1, up 1 over 1. We're making V's. Draw it in. We're only keeping that function between what x values? Everybody grab a highlighter, please, out of the bucket. If you need to, go and highlight. Look, -5 and 2. So watch, I want you to go highlight -5 and highlight 2. Like I just did there. So there's a highlight in the buckets, which are, your guys are on the floor, it looks like. Well, we're restricting it on that interval, right? So I highlighted those x values because that's what we're either keeping it between. So it's x values greater than -5. So look, is it -4 greater than -5? Guys, -3, -2, -1. Isn't 0 greater than -5? Everybody seeing how this works? Okay, but less than 2. So below 2 would be, so does everybody see how we're keeping it inside my highlights? So I'm going to go erase outside of the highlighted line because that's not included in the interval. So it's including -5. So go to -5, go up to your function, put a solid dot. Because it includes, the function's included, meaning at that function, at -5, that function exists. Boom. So then go over to 2 and go up to your function. It's not included. So 2, the function is not included on that x value. Does everybody see how that should look? You should all be fixing it if yours doesn't already look correct. Then, moving on to this. You guys should be able to graph this. This is a -1, correct? So let's first do the shift. Right 3, up 4, put a dot. This is -1 over 1, which is down 1 over 1. It's a reflection over the x-axis. So instead of going over 1, up 1, you're now going over 1, down 1, over 1, down 1, over 1, down 1, and so on. If you need to draw in the full V, I'm going to put in a few dots and only continue it where I need. Okay, so we're keeping that between x values of 2 and 7. So notice, I'm going to go highlight 7 this time until we get a little bit better at seeing it. There's my x value of 7. So we're keeping it between 2 and 7. Does everybody understand? So now erase anything else. I'm erasing those dots, that dot. Okay, draw it in. At 2, it is included. So go to 2, go up to your function included. At 7, it's not included. So right there needs to be an open circle. Not too bad, right? Okay, awesome. Guys, if we have questions, please ask. Like I literally left thinking you guys completely understood these functions. But then when I saw the homework, it was clear to me that we didn't. So we need to be asking questions. Because if I'm not making sense, and you guys all nod and say I do, I have no idea what to answer better or what to teach better. You know what I mean? Okay. So number 4, do we know how to graph a line? Do we know how to graph a quadratic? So that's, and if we don't, it's not a problem because you don't even need to know how to graph. Can't I literally just plug in 0 and plot points for 4x if I want? Do you get what I'm saying? You plug in 0 for x, what do you get out for y on 4x? 0. So let's say I have no idea how to graph it. I know that this point is on it. Okay, let's plug in 1. What do we get out? 4, so I know 1, 4 is a point. So if you don't know how to graph something, that should never be a reason to get it wrong. But I do know how to graph 4x. 4x plus 0 is what we're looking at. So our y-intercept is 0. Our slope is 4 over 1. It's a line, so I go Up 4 over 1. Up 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. Now let's check a few things, guys. So the reason I didn't spend a whole lot of time on graphing lines and stuff is because this is what we should have learned in as an 8th grader, is how to graph a line. So I just didn't go over it, you know what I mean? So I guess I should have spent more time on graphing a line. Couple of things to note here, guys. Degree 1 means it's line, right? This is the y-intercept. Mx plus b. B is the y-intercept, m is the slope. So do you see how this is a positive 4? Your line should be in the positive direction from left to right. So our line makes sense. Now we're only graphing that for x values less than 2. So let's go to 2 if we need to put in a highlight. Go to 2, put in a highlight. We're only keeping this function for x values less than 2. So let's erase anything above 2. Okay, now does it include 2? So go to 2, go up to your function and put a open circle. Is anybody confused? Okay, next thing, let's graph this quadratic. I know you know how to graph a quadratic, but let's say you didn't. Wouldn't you just plug in some xy points, guys? Well, we do know how to. This is a quadratic that's been shifted down 8, correct? Down 8. Then it's just a positive 1. So over 1 up 1, over 1 up 1. Now let's say you had no idea. What you would do is plug in 1. 1 squared is 1. 1 minus 8 is -7. So there's my point, right? Does everybody see how that works? If you needed to, let's plug in 2. 2 squared is 4. 4 minus 8 is, so we're at 2, -4. So I just know how quadratics work. This is over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3, 4, 5. Is everybody over 1 up 1, 2, 3, 4, 5, 6, 7. So it was over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. That's how quadratics work. But if we didn't know that, we could just plot some points. Okay, so now we would graph the other side too. Here's my next point. Over 1 up 1, 2, 3. Over 1 up 1, 2, 3, 4, 5. Over 1 up 1, 2, 3, 4, 5, 6, 7. But I'm not going to draw it in yet. So we're keeping the quadratic between x values of 2 and 3. So let's draw in another highlight. Here's 3. We're only keeping that red thing between those two values, right? So look, this, if I was connecting it, would come like this, right? Now we're not going to connect the rest because then we'd have to erase it. So let's just erase those dots. We're only keeping the quadratic on that interval. So now it's including 2. So go to 2, go down to your function and put a solid dot. It's not including 3. Go over to 3, go up to your function, put an open dot. That's what that should look like. So it just takes a little bit of thinking. It does. Like I said, this is one of the hardest lessons of secondary math 2, but it should be one of the easier lessons of secondary math 3, especially if we just use our logic thinking. You know what I mean? Like, oh, I don't know how to graph it, so I'll just plug in some points. Connect. You know what I mean, guys? Okay. Questions on that? Is that seeming easier now that we're seeing it again? Okay, good. That's what I was hoping for. Okay, everybody, go to number 16. I'm seeing a lot of people's graphs not look pretty enough for me. What I would mark wrong on a test, and we don't want that. We want to fix that before we get to the test. So a couple things. What does a cube root function look like? A sideways S, or an upward facing S? Sideways S, something kind of like that. That's just a rough sketch. So then we're going to determine the shifts to determine our new starting point. Or really what I want to see is this, because this is kind of, I call it foolproof, meaning anybody can get the right thing by doing it this way. So what is the parent function? Cube root of x, right? So this is what I want to see from most of you, because a lot of you are just doing rough sketches and that's not good enough. You have to have exact points. So let's plug in some values. What are some pretty cube roots? -8's 1, right? What's the cube root of -8? What's the cube root of -1? What's the cube root of 0? What's the cube root of 1? Cube root of 8, 2. Okay, perfect. Let's now take, and we're transferring this left 1. Isn't that a shift on the x left 1? We got to take all our x values and subtract 1. We'll do that. So we're going to subtract 1. I'm just going to write that by x. And then we're going down 3. Think about it, guys. That would be taking your function and shifting all your y values down 3. So we'll take it and subtract 3. Here we go. Let's write out our new XY points. This is what I want to see for most of you, because otherwise you're just doing too messy of graphs. 8 minus 1 is negative 9. Then we have negative 1 minus 1. Negative 2, right? 0 minus 1. And then 1 minus 1 is, and then 8 minus 1. Okay, moving on. 2, negative 2 minus 3. Negative 5. Negative 1 minus 3. Negative, or 0 minus 3. And then 1 minus 3. And 2 minus 3. Now we have these new points to graph, and it's that easy. So let's graph them. Negative 9, down 5. Okay, I'm going to plot that point. You guys are 2 on your graph. Checking it off. Negative 2, negative 4. So the reason I teach it this way is because then it's like I said, it's like almost foolproof, because if you're just plotting points and connecting them. So negative 1, negative 3 is a point. 0, negative 2. Cool. And then over 7, negative 1. Now you do have to kind of picture, what does this graph look like? You know, it looks something like that, right? So these are coming down, connecting, and coming up. So you just have to check to make sure, have I graphed all the available points that can fit on my graph? So look, do you see how looking here, this is pretty far over? I'm good. But let's say that it shifted so far over that this is the last point. And you might want to check by plugging in some of these values to see if any of them fit in the graph. And you can just plug those in right there, right? You guys all understand that? Okay, that's what I mean is I don't want just a rough sketch from there. You needed all those points. Does that make sense? Okay, awesome. Let's do number 20. Here we go. It's a square root function. So our square root of x. Now, do you guys feel like that's pretty easy, the xy point thing? Is that kind of how you're feeling like doing it? Okay, square root of x is our parent function. So let's plug in negative 1. That doesn't work, correct? Square root of negative 1 is I. Okay, let's try 0. 0, we get 0, right? xy of the parent function. You guys get what I'm doing? Just finding some parent function points. Square root of 1 is 1. Square root of 2 is a decimal. Square root of 3 is a decimal. Square root of 4 is 2. Let's keep going. Let's make sure we have plenty of points. Square root of 5, square root of 6, square root of 7, square root of 8, square root of 9. There we go. We better not miss that. Very good. And then what would be the next one? Just think about it. 16 and 4. Okay, let's just make sure we have plenty of parent points. Does that make sense, everybody? Now, aren't we stretching by 2? That's a vertical stretch. That doesn't affect x. It only affects y, right? So we're going to multiply all of our y values by 2. So we'll multiply by 2, we get 0. Multiply by 2, we get, multiply by 2, we get 4. Multiply by 2, we get 6. Multiply by 2, we get 8. Okay, those are our new y points. Now we're shifting left 3. So isn't that an x shift? So we'll subtract 3 from all of these. So 0 minus 3, I'm going to just write it over here so I don't have to rewrite it. 0 minus 3 is, so negative 3, 0 is a point. Let's graph it. Negative 3, 0. Cool. 1 minus, so we're subtracting 3. So 1 minus 3 is, so we're going negative 2 up 2. Negative 2 up 2. Cool. Moving on, we've graphed those. And then 4 minus 3 is, 4 minus 3 is 1. 1, comma 4. So over 1, up 4. Now, that makes sense. Let's keep going. 9 minus 3. 6, 6 is a point. So that fits, so we better plot it. Do you think any more are going to fit here? No. So we're probably good there. But all of those points would need to be plotted. Now, I want to show you, look at the pattern here. So it's up 2 over 1, up 2 over 3, up 2 over 5. So it's always up 2. They're all stretched out up 2. Does that make sense, everybody? So it really, like I said, you don't even have to think about it if you're just using this method. So we shouldn't be getting them wrong. All right, so now I want you to go to 7-3. I'm almost done here. We're just covering a few things to make sure we all understand what's acceptable and not acceptable. Okay, also on these, stating the domain and range, which hopefully I'm confident that you're pretty good at. Do we need to go over that? It's your guys' education. I'm willing to go over it. So with the number on these ones, do we need to go over domain and range? Let's just verbally state it. What's the domain and range on this one? What's the domain? All real numbers. What's the range? All real numbers. What about the domain on this one? Good. understand my range? Good, yeah, we're good with that. Okay, so we're learning something new real quick. It's this actually, I really like this one. And if you've been in my class from day one, we actually practice stuff like this. So remember when we were solving literal equations, meaning solve for any variable? We actually were seeing things like this already. So once you see it again, you'll say, oh yeah, I remember doing that. Okay, so if I said to you, find the inverse and it's an equation, don't we just switch x and y? It's not our first step when finding an inverse. That's what we learned last time. So we're on 7-3. We're on the pink worksheet. You haven't handed that in yet. Okay. 7-3, problem 11. So if I said to you find the inverse, the first thing we do is switch x and y. So you should all be writing this down. So remember, f of x just means y. So switch x and y. So we have x is equal to 7y minus 6 over y minus 1. Our next step is to solve for y using algebra. Now notice, there's two y's here. We can still find an inverse. We're going to get rid of all of our fractions using algebra, okay? And then what we're going to do is get all the y's on one side of the equation and everything else on the other side so that we can then factor out a y. And then we'll only have one y. So, let me say that again. Let's first get rid of not dealing with fractions. How can we get rid of y minus 1? Good. Times by that. Times both sides by y minus 1. Don't I need parentheses since I'm multiplying by an entire y minus 1? So this entire side. Okay, good. Now look what happens on this side. That divides out, right? We know how to simplify division. So over here we have this. Y minus 1 times x equals 7y minus 6. So rewrite your problem. So now what you're saying to yourself is, I'm trying to solve for y, but I have two y's. So I need to get those y's on the same side of the equation. Well, in order to do that, we're going to want to distribute this x through. So let's distribute this x through. Let's multiply everything out. So that's yx minus x equals 7y minus 6. Now, once again, your goal is to solve for y. So what you're going to want to do is get all the y's on one side of the equation and anything else on the other side of the equation. So we can go either way. I'm just going to bring 7y over. Is everybody comfortable with that? In fact, let's add x to both sides first, because I want to get x away from the y's. Anything that doesn't have a y, I want on the other side of the equation. So showing my work, on this side, I still have yx, those went away, equals 7y minus 6 plus x. Now, once again, we're trying to solve for y, so we need all of our y's on one side of the equation and anything else without a y on the other side. So when we subtract 7y, subtract 7y, so rewriting it, yx minus 7y equals negative 6 plus x. Is everybody feeling okay about this? Now look what you can do. The goal of that was to say, okay, now I have y's over here. Instead of having it in standard form or multiplied out form, let's factor out a y, because don't both of those have a y in common? Let's factor out a y then. Okay, we're pulling out a y. So divide by y, divide by y. So left is x minus 7, right? Now look, this is the same thing as that. This is just factored out, where this is multiplied out, and we have negative 6 plus x. Now look why that helps us. We only have one y, so we have one last step to get y alone. What are we going to do? Yeah, divide by x minus 7. So we'll divide both sides by x minus 7, divide by x minus 7, and y's alone. So we've reached our goal. We'll write it correctly. Y inverse equals, I'm just going to put this top part in standard form. So x minus 6 over x minus 7. And that's my answer. That's all you got to do. Which took some thinking, yes.
What do you do if it says, decide if the inverse is the function and say how do you
Good question. This is a function, so this is a function. Remember how we were graphing these? They were always a function. What would our domain be for this one? X cannot be 7, but anything else can be in the domain. So it's still a function. Does that make sense? It's just not at 7. So we would say this is still a function. Good question. So a rational is a function as long as x doesn't equal 7. So we would say yes for x values that aren't 7, or just x cannot equal 7. Does that make sense, everybody? Good questions. Okay, so let's do another one like that, and then I'll let you try one by yourself. Let's go through this one quicker. It says find the inverse. So our first step is switch x and y. Here we go. So we have x is equal to 2y. This is not on any worksheet. You're just watching. I wasn't clear on that. 2y minus 3 over y plus 4. So now what should I do? Times both sides. We don't want to deal with fractions. That's always what we'll take care of. So we'll multiply both sides by y plus 4. I better put it in parentheses since there's two terms. Very important. So those divide out. So over here, we'll distribute, right? So we have yx plus 4x equals 2y minus 3. Now we're trying to solve for y, so we'll get all the y's on one side and everything else on the other, right? So when I subtract 4x, and then when I subtract 2y, can I do 2 steps in one without confusing anybody? So we have yx, so we're subtracting 4x, and we're from both sides, right? And we're subtracting 2y from both sides. So over here, we have yx minus 2y, and then that's gone away, equals, that's gone away, and then we have negative 4x minus 3. Does everybody see how I did that? Now we want one y, so shouldn't we factor out a y? So left would be x minus 2 equals negative 4x minus 3. Last step, divide by x minus 2, and voila, we found our inverse. It is a function for everything except for when x cannot equal 2. That's our domain. Everybody good? You ready to try one by yourself on the whiteboard? Okay, go for that one. So, first thing, what should we do? There's many ways to go about this problem. Switch x and y though, right? X equals y minus 5 over 3, and then y plus 2, right? There's many ways to do this next thing. I'm just going to go ahead and multiply 3 and then rewrite this. Okay? So we have x is equal to y minus 5 over 3y plus 6. Is that true? Yes. Then what did we do next? We don't want to deal with fractions. Good. So multiply by 3y plus 6 to both sides, but we need parentheses. Divides out over here. So now we would distribute x through, right? 3yx plus 6x equals y minus 5. What's our next step? Subtract 6x from both sides. So what you're doing is you're getting y, all the y's on one side and anything else on the other side. So we have 3yx equals negative 6x plus y minus 5. Next step, subtract y from both sides, right? Getting all the y's. So 3yx, so it looks like some of you did get it right, equals negative 6x minus 5. Next step, we're trying to get y alone, so wouldn't we get factor out a y? Because now we can have one y. Factor out a y, divide by y, divide by y. What's left here? 3x minus 1. I'm glad you guys said minus 1. You're awesome. Equals negative 6x minus 5. Next, last step. Divide 3x minus 1. Divide by 3x minus 1. So it looks like some of you did get it right. Now y's alone. Were you close? Were you guys kind of close? Yeah. Hey guys, so it really wasn't bad, right? Do we need another one? Because I don't really know. I don't know. Okay, find the inverse. So okay, I'm going to go through it quickly. So we switch x and y, right? So we have x equals 3y minus 2 divided by 2y minus 2. Yeah? Then we would multiply both sides by 2y minus 2. So 2y minus 2 times x equals 3y minus 2, right? Next step, distribute x. 2yx minus 2x equals 3y minus 2. Get all the y's on side, anything else on the other. So that's 2yx minus 3y equals 2x minus 2. Factor out a y, right? 2x minus 3 equals 2x minus 2. Then divide by 2x minus 3. So how many got it 100% right? Good. Awesome. Good. Good. So Those of you that are still working on it, keep working on it. Hey, what I want you to do is go to the white page on 7-3. So 7-3, go to the white page. Number 23. We're going to answer this question. It says, find the inverse. Is the inverse a function? Find the domain and range of the original and the inverse. So make sure you're asking questions here if you have them. So, is everybody in the right spot? What's our first step? Switch x and y, right? So how about you guys quickly on your whiteboards find the inverse? Really quick. Or on your paper or whatever. Find the inverse of this. Just find the inverse and then we'll answer the rest together. This is quick. You got it? There's one step here. One step, right? You guys got it? Okay. So we switch x and y. So x is equal to 1/6y. What's the one step we have to do to get y alone? I like that better than divide by 6. Nah. We're going to do make it easiest on ourselves. Won't we multiply both sides by 6 like you said? Okay, good. Multiply both sides by 6. 6 and 1/6. 6 times the 6, guys, is 1, guys, right? So y is alone. Aren't we done? So our original f of x is 1/6x. Our inverse was 6x, right? Okay, let's answer this question. Look at the original function. What's the domain? So this should be very easy. Is it a line? Is it a quadratic? What does this look like? It's a line. What do lines look like from left to right? Negative infinity to positive infinity. Aren't all lines going that way forever and that way forever? So our domain on the original is all real numbers. So since we know that, what do we know about the range on our inverse? It's going to be all real numbers. All right, let's look at the domain on our inverse. Domains for me always is kind of pretty easy to look at. Isn't it also a line? So all real numbers for the domain. Thus, our original function's range will be all real numbers. So that one was easy. Now it asks, is the inverse a function? Is a line a function? Guys, yeah, a line is definitely a function. It passes the vertical line test. It looks like this. If you didn't know if that was a function, you could graph it and look at it. But if you just think about it, it's pretty straightforward. Okay, let's do 25. Let's give all real numbers. Yeah. So looking at 25, it's a quadratic, the original. It says find the inverse. So we would switch x and y, right? Now think about it. Isn't it a full-on quadratic? Okay, so remember that. Switch x and y, so you guys should do it on your own. I'm going to do it up here. You do it on your own. Did you get the same answer as me? Yeah. Perfect. So the original is x squared minus 2. My inverse was plus or minus. We can't forget plus or minus because this is reflective over that line. So it's going to look something like that. We need the top half and the bottom half of the square root. So this is plus or minus the square root of x plus 2. Okay. Now we can draw ourselves a rough XY chart here to help us out with domain and range. A rough sketch is good enough for this, for domain and range. Isn't this a quadratic that's been shifted down 2, guys? So let's draw a rough sketch. Down 2 and boom, boom. Correct? It's the upward-facing parabola. So what's the domain of my quadratic? Good. All real numbers. Isn't a quadratic going left and right forever? Okay. So what do we know about the range of our inverse? All real numbers. I like to look at domain because I think domain is the easiest, but we could, this range is pretty easy too, isn't it? So let's maybe would you want to just look at this range, the original's range, and then we'll know this one's domain? Okay, let's do that. So what's the lowest y value? Negative 2 to infinity, okay? Negative 2 to infinity is the range. So then our domain on our inverse will be negative 2 to infinity, right? Now check and see if you did it right. Isn't that a shift of left 2? And it's like this. So isn't our domain on this inverse -2 to infinity? So it does make sense. It's all really working out here. Cool. Okay, number 30. Here we go. So number 30. This is a quadratic. So what do we do with all inverses? Switch x and y. So we have x is equal to y plus 1 squared. What should be our first step to get y alone? We've got to square root both sides. So we have plus or minus the square root, don't we? Plus or minus in front of the square root on this one, right? Anytime we take a square root. And then that equals y plus 1. So next step is subtract 1, right? Now, is that subtract 1 under the radical? No. So we got to write it correctly. So our original was this, x plus 1 squared. Our inverse was plus or minus the square root of x minus 1, right? So what's the domain of this quadratic? Well, let's draw a rough picture to help us answer this correctly. Isn't this a quadratic that's been shifted left 1? Okay. And then it looks like that, no shift up and down, right? Okay, so domain for this is all real numbers. What's the range then for this? All real numbers. Now, we could look at the range for the original. What's the range for the original? 0 to infinity, right? So 0 to infinity. So then our domain for this one is 0 to infinity. Let's check to make sure that that's right. So if we were going to graph this, it's a shift of down. I'm going to graph it in red. Shift of down 1, right? And then it's the top half and bottom half. So is that domain right? 0 to infinity. Yep. So it is good, right? All good? Not a function. I like that you said that. Okay, awesome. True. Oh yeah, so when it says is the inverse a function, we'd say no. Good. Good point. Is this inverse a function? Nope, that's what our inverse was, so we'd say no. All right. Okay, last example here. So number 27, we would switch x and y, finding the inverse. So x is equal to the square root of y minus 1. Now that minus 1 is trapped under the radical, so we need to first take care of the radical. So how are we going to do square root? Square both sides. Root cancels out with power. X squared equals y minus 1. Next step. Add 1 equals y. We just found y inverse. So original function was square root of x minus 1. Inverse was x squared plus 1. I like to have a rough sketch for domain and range because it makes it really easy. This is a square root function that's been shifted right 1, correct? Like that? Okay, what's my domain? 1 to infinity. What's my range? 0 to infinity, right, everybody? Are we seeing it? Our range is 0 to infinity. So now we know these. Or we could just graph that and say the domain and range, but we can just swap them, right? So this domain is going to be 0 to infinity, and this is range will be 1 to infinity, and that does make sense. Yes? Yeah. We know how shifting of all functions works. So that's a square root function that's been shifted to right 1.
Oh.
So I'm just graphing what the original function would look like. Does that make sense? Okay, perfect. So won't the inverse look something, if we reflected it like that, it'll look something like that, right? Guys, you stamped it over. Okay. So it's not the full quadratic, but we're not going to get into that in here. Okay. Questions? Okay. Cool. So you're going to do the chapter 7 test review. This is what I call the easy test review. So next time we'll get a little bit more of an advanced one, but hopefully the easy one will be easier, pretty easy for you. So you're going to do problems 1 through 20. We're going to cross out anything that I do not put. So that's what we're going to do right now so you don't go home and do extra stuff. You're going to do problems 1 through 20. So we'll be crossing out 21, cross it out, 22, cross it out, 23, cross it out. Ready? Cross those out. This is on the test review, which is pink. The bonus test review is a different story. Bonus test review is white. That's the bonus test review. If you want to do that, you get a 5% increase if you'll do the bonus test review. Okay. Yep, so cross out those, then cross out 24. 25 we need to do. 26 cross out, 27 cross out. The rest you will do. Cool. The rest of the time is yours. Start checking, but you should be flying through these. Like, I need you to see what you can get done in the next 20 minutes of class. Because this is the easy test review. Like, this one should be it's very basic. It's like, let's just get to the basics and see if you can do the basics. Yes, so hand in what's due today. How about, I don't want you guys to waste your time. I'll come around and get them. I want you to start working on that. Okay, so I'm going to come right now and get your assignments that are due today.